13.3, we're going to explore trigonometric functions of any angle. So in 13.1, what we did when we were dealing with sine, cosine, tangent, and so on, we were only dealing with acute angles. And now we're going to be able to evaluate them at any angle, even obtuse angles. So let's start with our essential question. How do you evaluate trig functions of any angle? Not just the acute ones. And really, I mean, it does boil down to coming back to the acute angles, and you'll see that in a few minutes here. All right, so I printed this out for you so we didn't have to write too much. So example 1, we're just going to jump right into an example, and then we'll get into a little bit of definitions. So example 1, we're going to use the given point, and the given point was -3, -4, on the terminal side of an angle theta in standard position to evaluate the six trigonometric functions of theta. Okay, so I recommend, I wouldn't do this any other way, I recommend drawing this out, okay? So standard position means that we're talking about the coordinate plane. We're talking about an angle that is basically on this origin, okay? And we're thinking about the x value being -3 and the y value being -4. Well, where is x negative and where is y negative? Okay, so thinking about. So -3 on the x-axis, -4 on the y-axis. So my point is here, which means that when I draw this angle, it's coming from the origin out to that point. Okay, so this angle right here is the theta that we're talking about. Okay, well, the trick is that in order to do this, you're always going to need to look at acute angles, okay? Even though we're talking about, this angle, because in standard position, remember, it starts at the positive x-axis and it opens all the way to the terminal side. That terminal side right here is defined by this point. But what I'm going to do, no matter what, is I'm going to draw myself a right triangle. This is a reference triangle. And I'm going to use this right triangle to help me. Okay, so what I know on this right triangle is that the x value is -3. And then the y value is -4. So maybe I should have drawn my -3 up above. I'll just go ahead and do that, okay? And I've just drawn myself a right triangle. Well, this theta is going to have the exact same sine, cosine, tangent as the theta in this acute angle of the right triangle. So now this becomes a really easy problem. Well, sine, cosine, those both depend on the hypotenuse, and I don't have the hypotenuse right now. The hypotenuse will always be positive because it's not along the x or the y axis. Okay. Now, this should stand out to you as a Pythagorean triple. 3 squared plus 4 squared would give me 5 squared. So this is a 3, 4, 5 triangle. So I just used the Pythagorean theorem there. If you don't know your Pythagorean triples, then go ahead and set it up, right? -3 squared, which would really just be positive, plus -4 squared is going to equal hypotenuse squared, which ends up giving you 5. Okay, so now I can set up all of my 6 different trig ratios very easily. So sine of theta is going to be opposite over hypotenuse, so -4/5. Cosine of theta is going to be adjacent over hypotenuse, so -3/5. Tan of theta is going to be opposite over adjacent, so -4/3, which is really just 4/3. Now from there, the other 6 trig functions build on, sine, cosine, and tangent. So cosecant of theta is really the same thing as 1/sine theta, which is really the same thing as 1/-4/5, which if you do the math on that, you end up with the reciprocal, -5/4. Secant is the reciprocal of cosine. So it's really 1 over cosine theta. So that's really 1 over negative 3 over 5, which is really negative 5/3. Tangent, well, its reciprocal is cotangent. So cotangent theta is really 1 over tan theta. And this is really going to be 1 over 4 over 3, which is just the reciprocal of 3 over 4. So you don't have to write all this out. I'm just doing it this first time. That way you understand it. If you need to write it out, great. Otherwise, just know that, cosecant is basically the reciprocal of sine. Secant, the reciprocal of cosine. Cotangent, the reciprocal of tangent. Okay? So when you're doing these problems, always draw yourself these reference triangles. Okay? This is a reference angle, and that's what we're going to get into next. So let's define what a reference angle is. So a reference angle is, and we usually denote it as theta, but you could use any variable. It's going to be the acute angle formed by the terminal side of theta and the x-axis, which is exactly what I did up here, right? So starting with the x-axis, I opened up my angle, okay, and then I said, all right, the terminal side of that angle is here, and then I was able to draw myself this right triangle where this angle theta is now between the x-axis and my terminal side. All right, so we are going to find the reference angle for each of these thetas. Again, you're going to draw each of these, okay? It just makes it so much better. So, thinking of 140 degrees, starting at the positive x-axis, I'm going to open up to 140 degrees. Well, if I come all the way back to the x-axis, right, I'm going to be at 180 degrees. So I need to be 40 degrees short of that. So this right here is 140 degrees, but my reference angle is really what's left over. Okay, and I would draw, for me personally, I like to draw those right triangles. What is this reference angle? Well, that reference angle is going to be 40 degrees because I would need an additional 40 degrees in order to make it 180 degrees. Now, in your textbook, they use like a theta prime. Okay, actually, I think that's what I meant to do up here. So reference angle, we'll use, your textbook uses theta prime. So I'm going to put a theta prime there. Okay, or you can just write reference angle is. Okay, but theta prime here is going to be 40 degrees. All right, now let's do one with radians. Okay, so I'm going to draw this one a little bit bigger because it's going to be a little bit more challenging for some of you. So first of all, I notice that my angle is negative, which means I'm going to start at the positive x-axis, and I'm going to then go clockwise. Now, you might be asking yourself, well, what is 3 pi over 4? Well, the closest thing that I can think of to make that a whole pi is 4 pi over 4, right? 4 pi over 4 equals pi. So if I think about going pi degrees, or in this case, I'm doing negative pi degrees, that means I'm going to start here, and I'm going to work my way all the way over to negative pi degrees. Or if I was starting here and going counterclockwise, pi, and not pi degrees, sorry, pi radians. Okay? But what I don't want pi, I want to be basically a fourth less than that, right? Because this is 3/4 pi. So I want to be a fourth of a pi less than that. So right here, this angle is negative 3 pi over 4. And what's missing here then to get to that full, negative pi or negative 4 pi over 4 is basically a pi over 4. So my reference angle here will be pi over 4. So that's what this angle is here. And you could draw your little triangle. I like to have the right triangles. Okay, so theta prime, the way that your textbook does it, going to be pi over 4. Now, these reference angles aren't positive. They're not negative. Okay, we're just using them to help us figure out, like, for example, I could use this to help me figure out sides here. Okay. All right, so I just want to bring your attention to a couple of things. Going back to your unit circle, it's going to be really important that you remember, this is from a different class, but really important that you remember that cosine theta corresponds to the x value in your unit circle, or basically in the coordinate plane, and sine theta corresponds to your y value in the coordinate plane. So if I'm thinking of a coordinate in the coordinate plane, x, y, well, that's the same as cosine of some angle, sine of some angle. Okay, so there's a lot here, and I would not use this portion here, okay? I would definitely use this part. So we are going to evaluate trig functions of any angle, and here are your steps. You start by figuring out your reference angle, okay? Then you evaluate the trig function for that angle. And then you use the quadrant to figure out, okay, is it positive or negative? So for me, I'm not going to sit here and memorize all this. I'm going to think about my unit circle. I'm going to think about the fact that, cosine of some angle represents or corresponds to x. Sine of some angle corresponds to y. And then the rest of my functions are based on those functions, right? So if I'm thinking about tangent, well, that's sine over cosine. If I'm thinking about cotangent, well, that's cosine over sine. So I can just think about in which quadrants are my x's and my y's positive and negative. Just like we did here, right? So in first quadrant, x and y are positive. Second quadrant, well, y is going to be positive where x isn't. So if I'm thinking about tangent in this quadrant, I know that because these two signs are different, I'm going to end up with a negative. Whereas if I'm thinking about tangent in this quadrant, both signs are the same, I'm going to end up with a positive. All right, so this example asks you to evaluate. So the first thing we're always going to do is we're going to find that reference angle. Okay, so we're evaluating cosine of negative 150 degrees. So in order to find that reference angle, you draw it out. So negative 150 degrees, well, I'm going to start at my positive x-axis. I'm going to go clockwise. Now, if I go all the way back to the x-axis, I'm going to end up at negative 180. So I want to be just shy of that. So this right here is negative 150 degrees, making my reference angle, this angle right there, 30 degrees. Okay, so now this takes us back to our unit circle. So cosine of 30 degrees, that's really what we care about right here. Cosine of 30 degrees is really what we're talking about here. So you're going to look at the coordinates, okay, at the end of the terminal side, just like we did when we did the unit circle, right? So thinking about my 30-degree triangle, I know that my x value is root 3 over 2, and my y value is 1/2. However, that was in quadrant 1. Now this is in quadrant 3. So that would tell me then that my x value would have to be negative, and so would my y value. So negative root 3 over 2, negative 1/2. Okay, so I know if I'm looking at cosine, I'm looking for just the x value. Okay, so that tells me that this is going to be equal to negative root 3 over 2. That's your final answer. Okay, and I'm double checking that by thinking about what quadrant I'm in. Is cosine supposed to be negative? In fact, it is, because it's on the negative side of the x-axis. And if this was sine of 30 degrees, it would also be negative. Both cosine and sine of that angle are negative in the third quadrant. All right, let's make this a little bit more challenging now. Let's deal with radians. So cotangent of 16 pi over 3. So the way that I think about these radians is, can I make this into a whole number? So what would be the closest that I could, either my numerator needs to go up or down to make this into a whole number. So I'm thinking to myself, well, what if I did 15 pi over 3? That would really give me 5 pi. And where would 5 pi be? So let's draw ourselves a picture here. So as we went over with the unit circle, we start here, which is 0, but then you do one full revolution, you're at 2 pi. You do another revolution, that would be 4 pi. So add to that another pi, this will be 5 pi. Well, I don't want 5 pi. I want 16 pi over 3, which tells me I need to go another pi over 3, right? 15 pi over 3, 15 pi over 3 plus pi over 3 would give me 16 pi over 3. So I'm going to go another pi over 3 past 5 pi. That gives me my reference angle. So right here I'm going to have a pi over 3. I like to draw them as right triangles. So now I'm looking for the coordinates of pi over 3. Well, again, you either have these memorized, or you're able to convert them, or you continuously redraw your unit circle every time that you need to think about these. But basically, my reference angle here is the pi over 3, or the 60 degree. The coordinates of that are basically the 30 degree, but flipped, right? So 1/2 root 3 over 2. But I'm in this third quadrant, so I know that it's negative 1/2 and negative root 3 over 2. Okay, so that tells me then, well, my x value here would be negative 1/2. My y value would be negative 3.5. They're both supposed to be negative. I know that because they're in the third quadrant. Okay, so cotangent. So let's talk about cotangent. Well, I know that cotangent of 16 pi over 3 is really equal to cosine of 16 pi over 3 divided by sine of 16 pi over 3. All right, well, cosine here is negative 1/2 divided by sine of 16 pi over 3, which is negative root 3 over 2. Do the math on this, I really get negative 1/2 times negative 2 over root 3. Those 2's reduce. I'm left with a 1 over root 3, which is not acceptable. So I would need to rationalize my denominator. So I get root 3 over 3. So some of these will be really simple. For example, this one where I didn't really have to do much. I just had to figure out what's the point at the end of this terminal side, right? And cosine is the x value of that point. This one, though, required a little bit more because I'm dealing with cotangent. So I have cosine, I have sine. I have to do a little bit more work in order to get my cotangent.